So the first question, what is meant by saying that the bridge is balanced? There are a couple of different ways you can say this. The way that I would go for is that the potential difference between B and C is 0. You could say the potential difference, you could say the current. You're really saying the same thing. Is 0. So this is connected across here. It's been quite helpful to you here because it's given you R1, R2, R3 and R4. That's why I started with this example, because it's not really going to get any easier than this. It's a balanced Wheatstone bridge. It tells you there in the diagram, it says it's balanced. So anytime it says it's balanced, you can use this equation to calculate an unknown resistor. So it's R1 over R2 equals R3 over R4. It makes it a wee bit more difficult because you've got to substitute those values in from down here. You know, they're not written next to the resistors themselves, so that makes it a wee bit harder, I suppose. So you're looking at 720 over 320 is equal to 360 over R4. So you're going to solve for R4. If you do it the cross multiplication method, I don't have room to fit this in, so we'll just put it around here. So we're looking at 720 times R4 is equal to 320 times 360. So if you calculate the right hand side out first, well, this is obviously going to be 720 R4, and that's going to be equal to 115,200. Solve for R4, it's going to be 115,200 divided by 720, which is going to give you 160. So 160 ohms, just by applying this equation here for a balanced Wheatstone bridge and choosing the correct values. Made easy here because it gives you the values. Sometimes it might be harder to figure out, especially if you're using the diamond shape, but that's about as simple as it gets. Anytime it says that the Wheatstone bridge is balanced, you can use that equation to calculate what an unknown resistor is.